Hello, you're watching and listening to the episode of Leaders and Engineers. We are broadcasting from Riga, Latvia. My name is Nadar Yusupov, and today our guest is an expert in space technology, physics and computer science. He is a Bachelor of Science and Master of Science in Computer Science, and he has PhD in physics with more than 12 years of experience in space technology and deep space missions to asteroids and comets. He was awarded Harry Rowe Mimno Award from Institute of Electrical Engineers, or shortly IEEE, in 2016, and he worked at such places as Paul Scherrer Institut in Switzerland, Aalto University, Finnish Metereological Institute, and in Finland, and NASA in the United States. He is also an editor and writer of the Space Travel blog. He is now living in Latvia, and he's an associate professor at the Tartu Observatory of the University of Tartu in the Department of Space Technology. Please meet Professor Andris Slavinskis.
Yeah, hello. Thanks, Nadir, for traveling to Riga. Yeah, just adding there, University of Tartu is in Estonia, and I'm working remotely here from Riga.
Yeah, and thanks for inviting me to your place. We are in a beautiful apartment where Andris is living, and but this is always speciality. One of the specialities of this podcast that it's never done online remotely. It's always face to face.
Yep.
And yeah, I especially traveled to see you in Riga.
Thanks.
So, how's been how you been doing lately? What are the kind of news and?
Yeah, okay. So we're recording. Is it 5th of November, and October has been quite a month in my life and career. So we launched SCube 2, and results are not clear yet. But what we told is that it might have been remained on the rocket and deorbited already together with the VV23 upper stage, Vega upper stage. So that was a big hit early October, and yeah, we had to recover, rethink our plans. Still waiting for the investigation to be over, but yeah, did that, and then what I haven't yet mentioned online, where you got the details, was that we have a company in Latvia called Nanocraft, and just a few days ago I submitted the first proposal for doing comet interceptor modeling in 3D, and that's it's needed because the comet interceptor target is not known yet. And we would like to do an extensive modeling campaign with the Aalto University, University of Helsinki, and Tartu.
Mm-hmm. Awesome. You mentioned about this SCube 2, the latest mission. So do I understand correctly that the signal got established? Or?
No. Okay, so basically we couldn't establish the signal, and at first we thought maybe something is wrong with the EPS, all kinds of guesses, and then we received an email that they have a suspicion, and they're investigating an option that it just remain in the deployer of the CubeSat deployer, so it never got turned on and went back in the atmosphere with the rocket. And yeah, we worked on the mission since 2000, active development since 2015, maybe a couple of years earlier. So about 10 years work was put in that mission. Collaboration with the Finnish Metereological Institute on the plasma break E-cell payload, other payloads as well. And yeah, back in the time, it was very important mission because Aalto 1 was being prepared for the launch, still included the kind of old version of E-cell. And then we had a huge motivation to start something new, and then 4-cell projects came on later, and that is maybe the biggest driving force now in plasma break E-cell testing.
it's great to hear that you are working on many different initiatives, and also you mentioned about the company. But we'll talk about this more, but in the different format. As you probably know, in this podcast, the format we try out is kind of job interview, mocking the job interview for the leadership position. This is, I would like to underline.
Yeah.
Leadership position, but it's an engineering science company. And of course, company doesn't exist, product doesn't exist. But the questions, they are kind of typical to the job interview. So we will have this one. And after that, at some point, I will say that the job interview is over. And then I'll ask your feedback. Was it similar to your previous experience when you were hired and when you were hiring? And what are your total impressions? So are you ready?
Yeah, let's go.
All right. Hello, Andris.
Hello, Nadir.
Thank you for applying for a leadership position in our deep space technology company.
Yeah, thanks for considering me.
Our research shows that cats are better astronauts than human beings. And besides, we support diversity and inclusion, and we want to give cats right to explore space. So our company is designing a cat space mission to the moon. And in this position, you will be leading a team of space technology scientists and engineers.
Are they cats?
And you will see this on your screens. I will show to Andris how it looks like.
Okay.
I tried to put here a kind of Latvian flag. Tried several prompts, but wasn't successful.
Latvian flag.
But this image is generated by Stable Diffusion AI based on my prompt. So the prompt was that this is a cat going on a space mission to the moon. And but unfortunately, Stable Diffusion wasn't able to put up the Latvian flag. And what's so interesting is that when I didn't specify, I just specified astronaut costume. It was by default putting American flag.
Yeah. Well, statistically speaking, you're right.
Probably their data set is trained.
Yes.
Yeah. So my first question, why have you decided to apply for this position? What's so exciting about this cat space mission for you?
Okay. So sending cats to space is certainly a big challenge of human and cat kind. Because cats are famously hard to tame, and we have to accommodate their special wishes of getting food and getting, being pet. I guess that's the correct way to say it, I hope. And well, in terms of the mission engineering, we have to accommodate their fur shedding and then filter it out in the air and so on. So those are exciting challenges that we haven't yet tackled in space.
All right. But let's talk now, not specifically about this mission, but about your background. First of all, I would like to ask you, you started in computer science, then you moved into physics, now you're in space technology. How you, first of all, started this journey? When did you realize I want to go in computer science? When did you realize that you want to be in space technology?
Okay, yeah, that's a very good question. And basically in high school, I guess that's the moment in your life when you have most of the opportunities open. And I was really considering PR and cultural studies, things like that. But simply by looking at my track record as a pupil, I was definitely better at exact sciences. And I was drawn to computers basically since I remember myself. In the first grade, didn't have a computer at home. That was middle of 90s in Latvia, I was going to school, and although I grew up in the countryside, we had a very progressive school in Slampe, Zemgales Vidusschool, where they had computers already back then, and I was making crossword puzzles for my teacher to give to my class. Probably my classmates hated me.
In which language you programmed?
No, in Excel.
Okay.
So it's crossword puzzles in Excel related to the topics in school that we were learning about.
Right.
And as soon as we had a computer at home, I was the primary user of that computer, often breaking it down and collecting all the digital stuff that you could get at the time, including, music, another big passion of mine. And then in high school, it seemed like the most suitable option for me. And because I was so familiar with computers, while physics was okay, math was okay, but like chemistry, biology, not so much, for example. So I didn't feel like a natural science person. And I think computer science is an interesting field because it is part of the nature, but it's built in a very specific way in order to do very specific things, like, moving bits around. Okay, so I because my girlfriend at the time wanted to study translational studies, I went to Ventspils University of Applied Sciences, it's called nowadays. It's a small university in Latvia on the west coast, like California of Latvia. And studied there 5 years in total, bachelor, master. And it was an amazing environment because basically you had like independent groups of students forming and teaching themselves, teaching each other. So yeah, studying was fun for me, at least. And then in masters, I went to Lund University, Sweden, and I was going in depth with numerical analysis. At the time, it interested me because it was a more advanced application of programming. I didn't feel like writing home pages, and I also felt, and it was definitely right, that if I know how to model differential equations, the field doesn't matter anymore. Differential equations are everywhere. And in-depth numerical analysis, scientific programming in Paul Scherrer Institut, still during masters. After masters, a total several months of very, very depressing time, trying to get a job, trying to figure out what to do, until I realized that I could join my friends in Tartu. They have started their studies already. They helped me to get a PhD position. I did not go for physics, but anyway, the main point was to do SQ1 or electric sail for me personally, but it turned out to be mostly SQ1 work at the time during my PhD. And, I think in what we do in S-Cube and 4-cell, if you are designing a mission, you need to know physics, otherwise you're a bit lost. And I had to catch up with a lot of physics. You can see a book right there, Understanding Physics. I've read that as part of my exam, PhD exam, which for physics undergrads would be simple, but coming from computer science, it was one of the hardest challenges I've gone through. And after PhD, again, pretty depressing time because it is very heavy work to get a PhD, but your future is very uncertain. However, my supervisor was changing position to vice rector, so he established the Space Tech department in Tartu Observatory, established SQ, did a bunch of other things, and then he was wrapping up everything and moving to a vice rector position. And he gave to me the department and SQ. And that's already a lot. I don't know how he managed everything at first. And from there, that was previously in SQ, I had team lead experience, multiple years. And then in the department, I was basically straight out of PhD, doing professor's job, writing proposals, leading projects, and starting to supervise PhD students. And at that time I realized I also was reading, because my mental health was crumbling. I was reading about meditation and Buddhism, things like that. So at some point I kind of just told myself that I will get through this. I'll continue working on SQ2, which was the main project for us at the time in Tartu, and the main opportunity. And I have to kind of filter out my own emotions when I go into working with my partners, with my students. And that was, training by doing. And sometimes it's like you're sitting in a meeting and emotionally might be destroyed, but you have to still act professionally. And I guess that at the time when others do postdoc, I was doing that, but I guess it was a very just rapid postdoc experience, so to say. And after that, so in Tartu Observatory, they had arranged a contact with NASA Ames, and they offered me to go there for a year. And I was kind of had to choose myself, where do I go? I have to travel there at first to establish a better plan. And I chose to go to the mission design division because I felt that that's like the fundamental skill you need in order to grow in space tech as a leader, as a professor. You have to be able to come up with concepts and develop them to basically from ideas to engineering. I feel that that's the range where I'm most comfortable with, and I think we did something similar together on Force L2. So mission design, I was working on multi-asteroid touring, and that was Pekka Janhonen was in leading that concept. But I had the chance to apply the mission design methodology to already existing concept and develop it further, give it to my PhD student Jaroslav later on. And after, maybe funny way how I ended up in Aalto was that I was in summer school in Tartu. Jan Prax was there, we were having beers. Jan Prax is from Tartu, and just hanging out. And at some point I tell him that, hey, my wife might work for Starship in Helsinki. Maybe I can have a desk in Aalto. I don't know. And he's like, well, you can have a postdoc position. I'm like, okay, sounds good. I'm going for that. So that's how we met, basically. After that, a few months later, I was in Aalto and we started to work together.
That's actually shows the importance of the networking. In your life,
I organized and invited Jan to that summer school. So although we knew each other for years, but we needed that special time in the bar to come up with that idea that I could work for him.
How often in your life it happened that some kind of career advances or some agreements were reached informally before applying?
I would say always. It sounds maybe a bit wrong if I say that it always goes through contacts, because we have this post-Soviet background of blood system, or I don't know what you call it. I don't mean that. I mean that at the end you go for a competition in a proposal for funding, PhD position, whatever. Someone is evaluating your ideas.
Mm-hmm.
But when ideas are born, they're often born in a place which is not formal at all.
Mm-hmm.
And my experience, probably one of the rapidest changes in my career has been through Comet Interceptor, where we go to ESA headquarters with multi-asteroid touring, which includes ESAIL, which ESA doesn't like, not ready yet for flying in space in science missions.
Mm-hmm.
So, the ESAIL part is played down during that meeting, and I expected that. But maybe what I didn't expect was that they invited the best European small solar system body scientists in one room. And later on, we went on having beers. There's Colin Snodgrass, Karen Jones. They were the leaders. They proposed the Comet Interceptor later on, which won. There was Matt Taylor, just, casually chatting and so on. I would say it is extremely important to meet people in person, go to conferences, go to meetings, and then on top of that, we'll go out and have dinner together. And then you make sure that you are on the same page. I would say emotionally, like you have the same gut feeling. And then when you start to work, of course, things change and improve and so on. But trust, without that, we cannot really collaborate, I think.
Agree. You mentioned you went through ups and downs, like probably any normal person would do. And you read those meditation books. But what's so interesting here, you're also dealing with the space. And when you add space, then you read these meditation books. First of all, did those meditation books help you to go through those challenges? And secondly, connecting with the space, do you see some kind of, do you believe in something supernatural, some creatures out there?
Okay, yeah. These are very, very interesting topics. First of all, I started in 2015 as almost like I'm scared of meditation, but I'll try. I was like, I try to do 1 hour a day. And if I don't do it, I feel worse. It's usually kind of getting back on the track means restarting meditation, maybe some other practices. Mm-hmm. And yeah, when I started meditating, I was an atheist. And then only through different practices and experiences, I realized that what is the thing that people call spirituality? And I guess what people, it's like supernatural things like God, would be one interpretation of just kind of experiencing something different than our day-to-day life. My, like a bit maybe scientific approach is this, that we are filtering reality all the time. Our mind is a filter basically, and we can understand things in context. We're making a lot of shortcuts in our perception, in our thinking, and that is helping us to survive. And be it a professor or a student or someone who is trying to survive in forest. So those skills are very much needed. But at the same time, what we understand less, what they understand less is emotional side of us. There are theories that say that, your mind is in left hemisphere controlling your right side of the body, and then your emotional side is on the right hemisphere controlling the left side of the body. And the connections between both hemispheres are defining in how you feel. Sometimes your mind and emotional worlds might not be aligned because you have not contemplated enough about some kind of aspect of your life. So for me personally, it's more about these, that I have to admit that there's emotional side of me which is real as the practical side, and I have to maintain that the same as I maintain my physical body. If you call it, God, it doesn't really matter. I think it's, interpretation,
but
intent matters.
That's a bit trivial question, but anyways, do you believe in aliens? Do you think there are some?
Yeah. Okay, do I believe in aliens? My answer is that most likely there should be something else living in the universe. but we have no clue about it.
Have you watched, by the way, this movie at Astra with Brad Pitt?
Astra, no, I don't think so.
In this movie, he's actually traveling after his father. I want to to spoil, but it's also connected that it's kind of talking about the future where people got more advanced with the deep space traveling.
Okay.
But quite an interesting movie. I would really suggest to watch that one.
Well, I like Brad Pitt. I like The Expanse, which is a series taken over by Amazon later, and it's ended now. And that has basically a whole. It is based on books that where they develop the whole universe of people living in the solar system and different ways of living, and are developed. Exciting stuff. So I can look up the Astra as well.
But continuing about your experience, you've been to NASA, and for many, this is really like a dream to get there. What does it feel like to work there in NASA? What were the kind of key takeaways for you from there, from your experience there?
Yeah. Okay. So of course, it is a dream, and I for a long time I could not believe the stuff that I'm arranging for myself, and even being there, like sometimes you're like, am I in a movie? It looks like in movies. So, what was the question? Sorry.
How would you describe your experience, and what key things you learned from there?
Yeah, okay. So the experience, I guess what the best way to describe NASA is that every single person there is good at their job, and almost everyone works in space, So if I go to a colleague who knows trajectory design, for example, he can give me a simple preliminary trajectory in minutes, and he works, I don't think that fast as he clicks around SDK and does it all. So I guess what the most important thing there is that they're extremely experienced, and they also have a program where they educate people, and they look for the best ones. At the same time, NASA Ames is in Silicon Valley, where working for NASA Ames is not the coolest thing. So it's a bizarre place. I recommend visiting, but it's also a strange place, actually. Stay for longer, which I definitely didn't want to.
What was the strange about it?
Everything is about work. Like
you mean this culture, Silicon Valley culture?
Yeah. So people define themselves through work. They're willing. A lot of people go there to hustle, grow up fast, a lot, earn a lot of money, and so
these are the people who trying to find out how to sleep less.
Probably, yeah. The like biohacking is very used to be common back in the day. There, I don't know what's common now. Maybe meditation.
And you had experience working and living in US, in Finland, in Estonia, and Latvia. How would you compare all those different experiences?
Oh, wow. Yeah. Good one. So I think I feel the most comfortable in Finland. I think that would be my ideal place, but my family and friends don't live there. So,
but why? You felt more comfortable there?
Okay. Yeah. I come from post-Soviet world where you kind of have to keep a radar on all the time. People can get angry at you. People are not polite. They're passive-aggressive, things like that. And it shows also, we talk about leadership here, it shows up in workplaces as well. And then in Finland, you can turn off that radar. You know that everyone will be friendly towards you, especially in universities. Everyone will respect you and so on. And this kind of I like the flat hierarchy, and also been in Sweden where that is very predominant. And indeed, by going to Sweden first time abroad, that opened my perception in terms of how can you interact between professor and student, for example. So a leader and someone who is learning in general terms. US, US is a cultural shock, I would say, for a European, because everything is very similar, but at the same time, there's twist in almost every aspect of being in the US, and laws are a bit different, and then the way you establish friendships and relationships. I'm not saying that they're very, very friendly, of course, Americans. However, they're kind of, it takes more effort to switch to this new cultural mode. And I guess me and my wife were able to do it. We made a lot of friends in the US, but we feel more relaxed in Europe.
Mm-hmm. But cultural shock, it can be positive and negative. I mean, cultural shock is something different. But you can say, oh, they're doing things differently, but actually this is better. Is it the same feeling you had, or it's opposite that, like, no, it's actually in Europe, it's actually better? How we do?
Okay, so US is certainly better at entrepreneurship, making companies, at scaling them, and making it big. And there's a very strong hustle culture that, American dream, people go for it. I think in Europe, and especially in Finland, people would definitely take their time off and they would respect it. Well, and it can be 1.5 months in Finland, I guess, in academic world, 2 months. In the US, you get 2 weeks when you have experience. And you get even less before that. Basically, working in the US means almost constant work. People often check email during vacations and things like that, which is common. Like professors do it in Europe as well, but it's not done throughout the whole system.
So it's basically more work-oriented rather than kind of personal family spending time. So in Europe, it's more focused on the giving you personal time, private time, and
yeah, definitely. Europe respects your free time, your holidays more. Social, yeah. I mean, Sweden and Finland are social countries, not like the socialist Soviet country, but just that you have a lot of social buffers, and that reduces anxiety.
Some kind of the support net on which you can fall in case of some kind of when you want, when you have want to have rest, or you want to take a pause.
Yeah, so that would be much more supported, I guess, in Finland, and as compared with post-Soviet world, where maybe mental health is not that real yet. Yes. I've been to therapist, auto pain therapist, and I needed a session or 2. I don't remember, but it's definitely something extremely valuable when you lose some kind of connection, or something is not going well at work. You can have a totally independent person helping you to analyze the situation, for not analyzing it for you, but answering the important questions. How is it looking?
You also mentioned that in the latest meeting you had ESA, European Space Agency headquarters, you spoke about this e-sail, and they were not so kind of enthusiastic about that, but you are working with the e-sail and also with Pekka Janhunen and with other people involved in this. what's the future? What's kind of the roadmap you have with the eSail?
Okay, yeah, that's a good question. Of course, I can quickly say what is it happening in Finland and then focus on my own work in Estonia. So, Forcell consortium are launching Forcell 1P, which is the next opportunity to test plasma brake in low Earth orbit. Then Aurora Propulsion Technologies are running European Innovation Council project, which is huge. It's the biggest funding ESA has received probably. And they also have ESA support by now on plasma brake. So what has happened in the last 6 years towards ESA attitude towards ESA has changed. There's real development money being invested. So what we do in Estonia, basically we're living in a post-SQ2 world. What exactly happens with the SQ2 project, we are not yet sure, because being investigation results and then some hard thinking where to bring that student project effectively, which has a lot of other interests, not just eCell. And what I've been working for the last year is the SQ Lunar Nanospacecraft concept, or SQ Luna concept, where we have designed an eCell experiment in lunar orbit. It's very good because the solar wind is there almost continuously, and it is also close to the Earth, so we can have regular communications. What is another benefit in lunar orbit is that we can use the moon, the Earth, and the sun for navigation. So we solve the triangulation problem based on wild field of view navigation camera images. The biggest challenge in deep space CubeSats is the communications, I think, because, well, it relates to, of course, operations and autonomy. Basically, all the deep space CubeSats we heard so far from space agencies, they use deep space network. Yes, Artemis 1 CubeSats all were,
On this, was called to Mars, they use X-band.
Yeah. Of course, there's DSN support from JPL to all NASA missions, and Europe does not have deep space CubeSats, I guess, yet.
But you don't have access to this deep space network?
No. So accessing deep space network is basically, you need to have a space agency mission. If it's deep space, most likely it's
They will not,
science mission.
They will not like kind of rent out you the retranslator. Like, several.
But I know that these facilities are very busy. And what we have done over the last year is that we have established a plan to collaborate with Ventspils University of Applied Sciences, the same place here I did my bachelor and master's. They have a 16 and 32 meter radio telescopes in Irbene, Latvia. Maybe one day you can interview someone there. It's incredible. You have to drive a bit further. And and that would be one of the facilities we would use to replace what is currently done with deep space networks. And for the SQ Luna concept, that means getting high rate data communications with some kind of pointed antenna, and also doing ranging. And then for low speed communications, we're considering turnstill antenna solution, which would be, more or less independent of the satellite rotation. And ESAL is always rotating, so that is another aspect which we have to consider and all the time include in our plans when we are designing the mission. Certainly very challenging, but also exciting, and I guess several PhD, master, bachelor thesis topics coming out of it recent months, in upcoming months, sorry.
I can imagine that compared to other engineering and scientific endeavors, this is challenging because even with this S cube, it's really hard. You are limited in the tools which you can use for debugging and this kind of feedback loop when you set something very far.
Yeah.
And especially when we speak about the deep space, and not to say about the cost, how many times you can try all this. But yeah, the question I also want to ask, we live in very challenging times, lots of, I would say, awful things happening around the globe. And you as a person dealing with space and looking into up, maybe not looking what's happening on the Earth, how do you see the future of space in terms of, do you see there will be more militarization, and how do you feel about it?
Oh, wow. That's a heavy one. So basically, wherever there will be human, there will be militarization.
But in space, you see this also.
Well, I guess every major space power is making their military branch as of now, and including NATO. And if we talk about humans going to space travel, science, I don't know, lunar habitats, like one of my dreams is to, in my lifetime, to see people on the moon, regularly living there, traveling and so on, having artificial lights coming off the moon's surface. But that will require someone take care of, force the law, basically, if you talk very bluntly. And you don't need it currently for astronauts, which are extremely educated and which are trained to be in these incredible situations. So if we send more and more people in space, then we have to think that they might be bad players and something going off in someone's mind, and we have to control that, I guess.
In this Ad Astra movie with Brad Pitt that I mentioned before, they're showing future where space technologies are so advanced, people traveling easily to moon, then to Mars, and to other places. But what was so interesting is that the moon they were showing is divided between countries, and they are kind of fighting there, and there are even rebels on the moon.
Yeah.
Do you see this is very likely?
Okay, so the idea of a nationalistic country is not an old one. So it is fairly recent that we have divided the whole world into political map, where almost every bit of the earth belongs to someone, whatever that means. So we have defined our countries, our international laws that are written by humans, but that are running this planet. So it is hard to imagine that things will change if we go to the moon. What I can imagine is that if I'm leaving all the Earth legislation behind, I can indeed start something totally new in space. And but a new civilization in space requires hundreds of thousands of people, and I guess we cannot do it independently of earthly countries, and that means that these interests will travel, I reckon. Something similar what you said in Astra, and actually the Expanse is also similar. They have Martians and Belters, and then there's huge tension with the Earth. So they don't represent the countries as on the Earth, so it's already a bit further in the future where there's enough people on Mars and in the belt that they can be independent. But of course, they all came from Earth and then started off as representatives of UN or something like that.
Yeah, this is challenging question with no of like one bullet answer. I mean, the one who figures this out probably should get the Nobel Prize for Peace.
Yeah. Well, I guess it is, well, we also give Nobel Prizes in economy, right? And basically by advancing earthly economic theories and practices, people get these huge awards. And then in space, we have to rethink everything. It's not just some crazy professors and students making crazy space technology. It is medicine, it is law, and indeed like human interactions and governing structures. I guess there's the meme about some kind of idealistic automated space capitalism, so hinting that we could reimagine how things work in space. But it's not like, I don't think that it's necessarily bad that we look at the country models of the world. And if you say Finland, for example, that seems to be a good model how to run a society where people are fairly happy despite the dark winters.
The happiest country in the world, according to various polls.
Yeah, I can kind of see it. And I think it's not just this like, couple of glasses of wine happy, but really people determined with their lives towards their passion, and that's driving them, I guess.
And if you speak now about more about what is the mission of the company, and
Right,
we want to send Cat to the moon as a cat astronaut. So, given that our mission is unique and involves sending a cat to the moon, how do you think your expertise in physics and computer science will be beneficial for the project success?
Okay, excellent question.
By the way, I have to mention, now the question I asked was generated by ChatGPT.
Yeah. Okay.
I gave to ChatGPT your description, like how I introduced you, and I said, this is the guy I want to hire. What questions should I ask this guy? And the ChatGPT gave me a list of questions.
Yeah. Okay. So basically, in order to maintain a clean and healthy environment for the cat, we need to develop an ecosystem, which is kind of a small world based on sensors and filters and, I don't know, air mixers, things like that. I guess that's a lot of physics in making the fundamental building blocks of this system, and then we need the mind or the brains of it all, so that's computer science, so making it as much as possible automated, so we can scale things up and have hundreds of cats on the moon. Catocracy.
So you think you should send not one, but to make sure that they reproduce there?
Yeah, I'm just like, there are cats running around my neighbor. Yeah, it would be nice to have cats on the moon.
I know you have a dog, so probably you are not a fan of cats.
Well, I know I like cats, and maybe it would be somewhat easier to work with cats at first, because they require less human attention. They can be more independent and prefer to be left alone oftentimes, as opposed to my dog, who is tonight at 5 in the morning. I was coming here to sleep with the dog because he was a little baby and crying for some company. Yeah, so dog. I think the problem with the dog is that it is bred according to the human need to have a companion, and while the cat is being bred to, be a independent agent catching rodents.
Now, can you tell me what are the top 3 things that you think you need to improve in yourself?
Okay. Yeah. Top 3 things to improve in myself. I would really like to find a way to reduce not necessarily the stress that I experience. I don't think I can control that, but my how I react to stressful situations. So establish kind of new habits and maybe having a bit more foresight of how the things will evolve. I would like to I'm writing a lot already, but my ambition for the future is to write a book. So I guess I should be comfortable spending not just weeks, but also months in writing kind of the same text. That is something that currently, as an idea, scares me a bit. And last thing that comes to my mind now is that apart from the job interview, as I'm a co-founder in a company, then and with a heavy academic background, then I'm a bit scared about the commercialization part. I have a partner for that in the company, but kind of getting to know those processes, which is maybe less engineering, but more thinking of how the world works in terms of human interactions and so on. So how do I convince someone to buy my product?
This is actually very relevant to many scientists and engineers. It's kind of or people from art as well.
Yeah.
You have different mindset doing this stuff, and then there is this business world where you need to bring up kind of finances and making this business case.
Yeah.
You want to learn this. What's the most challenging thing about that you find about? Stepping out of the shoes of the scientist and thinking about this business practicalities.
Okay. Yeah. Well, I'll start with a bit background that I feel that we're building some kind of pillars, and effectively those are human experiences that hold together a research group or a company, so that every day we can get to do the right thing or trying to guess what is the right thing to do. And then I guess for me personally, I've been building the engineering pillar, the science pillar, the networking pillar, and to a large extent, I can copy paste those in the company. As someone working in a university, selling my ideas is a bit different story than selling a product, I guess, because in the product, everything has to work already, while as a professor, I'm more paid to generate ideas, get them to the first proof of concept, first proposal, get funding, and oftentimes then engineers take it over, and they can have fun. I can move on to the next thing. In a company, almost no experience in finance. Therefore, I needed Guillaume. Well, you know Guillaume, maybe. Did you work together? He also worked on Forcell too. So I contacted him when making the company, whether eventually he could join the company, commercialization/finance. That's something I'm totally lacking. But when another pillar that is lacking in science often, or in the research environment, is the artistic side of things. So we do make science outreach, space travel blog, you mentioned that. I work with artists basically on a weekly basis, define concepts. I can show my drawings and then how they look online, totally different look. And in the company that comes in with a graphical user interface, also user experience, I would say that artists are closer to that than engineers. And that's something basically among not co-founders, but affiliated people with my own companies that have an artist, Anna Maskova, the same artist from the blog, with an idea that when we start to build a commercializable product, then I have an in-house support for that. We plan to use Unreal Engine 5, so that's for real-time 3D modeling, and obviously comes with that graphical user interface that we would like to take advantage of.
The other question, which is also very, very important in different setups when it comes to students or companies, how would you motivate people to perform better, who, let's say, in your team?
Yeah, okay. I guess in that sense, I'm a quite single-minded person. I try to generate the most exciting idea and then see who is lighting up when I talk about it, and it's clear that those people want to work with it. That this I guess this kind of loose supervision and relationship, and I do work with high schoolers, bachelor students, not paying to them, but I keep them around with the interest. So as a professor, that is certainly the biggest key of running things is generating interesting ideas. And oftentimes students are, at least students in Tartu, it's more about engineering, so I just have to make it challenging from the engineering point of view. And then what we do with Pekka and with Jan, for example, then it would be defining science so that it leads to I don't know, nature, science papers, something like that, eventually, someday, when we succeed, so that we try to check as many boxes as possible. And then now a bit imagining how to translate this to a company is that I guess our big nature paper is some kind of investment or an exit, when you can say that, yes, we succeeded with that. While on the motivating people, I guess I'd have to be less entertaining with my co-founders and with the people involved in making the company. But still, the ideas are what matters in startup world. Like founders and ideas basically matter. And thus far, we're thinking 3D mission design tool. Maybe we can change that idea, but it had to be interesting enough for my co-founders to say, yes, I want to do it. So I guess very similar principles work, but I communicated much more bluntly to my co-founders than to students.
It's actually a good point, because I remember when I was with my co-founders going through various ideas for the startup, we had 3 criteria. 2 are like always open. They are kind of standard, pretty much, like importance and feasibility. But then we understood that along with the importance and feasibility, will not go far. So we added another 3rd criteria, level of excitement. How much it excites you.
Yes.
And then we took this as a priority number 1. So we made top 3, shorted this list based on the level of excitement. And then we defined them on the importance level and feasibility.
Yeah, and I think that is a good approach. I personally feel that the idea has to be clear enough to go to a knowledgeable investor and say it in 4 sentences. You don't need a long meeting. You don't need your slide deck. You have to be able to say clearly what you want to do to someone who understands the better. And then the slide deck is for someone who doesn't, I guess, or for fixing things more clearly. And that can only work through getting a bit excited. So, this kind of Airbnb of something thing that imagine you have that product with a new function, and if that idea excites you, then yeah.
Now I want to give you a scenario, kind of use case, about change management. And so basically I will read you kind of like a story.
Okay.
And the question would be, how would you solve it?
Okay.
As a leader of this team.
Yeah.
In a not so distant galaxy, there existed a pioneering space industry company known as Galaxy Tech. They were renowned for their cutting-edge technology and innovative spacecraft. But even in the limitless expanse of space, change management was a challenge they couldn't escape. Galaxy Tech had been a major player in the industry for decades, but as the cosmos continued to evolve, they found themselves facing the pressing need for transformation. They needed to adapt to new propulsion technologies, incorporate sustainable energy sources, and embrace the rapidly advancing world of AI-driven space exploration. At the helm of Galaxy Tech was Captain Sara Astrona, a visionary leader who understood the necessity for change. She recognized that the company had to evolve to remain competitive and contribute to greater galactic community. However, implementing change in a space company was no small feat, and the resistance to change was as vast as the universe itself. The challenges in change management were epitomized by a group of veteran rocket engineers known as the Asteroid Guard. These engineers had spent their entire careers building traditional rockets with traditional materials, and they were very deeply skeptical of the new technologies and methodologies that Captain Astrona sought to introduce. The tension between the Asteroid Guard and the younger forward-thinking engineers led to a divide within the company. Change was seen as a threat to the status quo and the well-established traditions of rocket building. The older engineers argued that the tried and true methods had served them well for decades, so why fix that what wasn't broken? How would you are in the place of Captain Sara Astrona?
Okay. It's very funny that you chose that name, because sometimes when I'm in a maybe similar situation, I think that what would Sara Seeger do?
Oh, I didn't choose this name. I describe what I want, and I told to generate.
Yeah. Okay. But yeah, Sara Seeger inspires me as a leader, certainly. So, the example you show is basically you can translate it to the our world as ECSS or space standardization, and then startups, new space guys coming in and wanting to do things differently. I guess the main motivation to go for new ways is that we can do more with less resources. We can, shrink the spacecraft size. In case of propulsion, maybe we can consider propulsion systems that don't require propellant tanks, so we can drop those. But we have to, so basically, whenever we remove something from the design, like as a kind of a big thing, we might need to get smarter in how that remaining thing works. So I guess if you look at the first CubeSats or second generation of more smarter CubeSats, and you compare them with the operational old space satellites, then CubeSats might have more functionality and more flexibility, although built by students of tiny teams, and but just reusing a vast access to consumer electronics and tools to develop them. Approach to do that, I guess, I have thought about this in the context of space agencies, is that standard is there for a reason, and kind of a foolproof way to make sure that the thing will work. But you can also make mistakes if you don't understand how the standard works, of course. But before you try to standardize something, you can have this time of developing it freely without any restrictions. Then come up with the best kind of minimum viable product or prototype that you can have, and then show it to the old guys and say, so how do you standardize this now? Where can we go with this? And if we make the connection with eCell, then it would be very, like, it felt that 10 years ago, it felt that ESA is just simply against eCell. But it wasn't the case. They simply follow their rules, their standards, and they say that technology is not ready yet for us to use it. And if you contemplate about long enough, then you think that, oh, I have to be the one developing it, testing it.
What's the current technology readiness level?
Well, I guess we haven't increased because we haven't had more attempts, so TRL4, somewhere there.
It has to be 8 to get qualified, right, for the normal space mission?
Well, for operations 8, yeah. If it would be a payload, then 6 is fine. But yeah, for a propulsion system, I guess we would need to show it on like some kind of S-Cube Luna type of concept in operational environment, doing some kind of trajectory changes in order to say that it's a propulsion system. But yeah, I think eCell is standardizable, and it must be standardized one day, but we're currently not there yet, and it takes so long. So my answer to the Sarah Astron problem is that then young guys can do independent work. It does not have to fly right away, or it can fly on something much cheaper in order to see if it works. Feasibility, if you say that you want to do things in a revolutionary way, then you need the revolutionary proof of that anyhow.
Kind of maybe what SpaceX did.
Yeah, certainly.
It's a rocket, but they made it cheaper to launch compared to what was from this ULA and Ariane from the ESA, those kind of rockets.
Yeah, absolutely disrupted everything, and I guess Europe is trying to figure out what is happening with their rocket industry.
Mm-hmm. And this is also very relevant, important question nowadays. We are living in a world where there are lots of wireless connections, starting from this Wi-Fi, Bluetooth, ending with the 5G. Well, 5G is de facto everywhere. I mean, whichever country you take.
Nowhere's here.
You did a lot studies in physics. How do you feel, or maybe some kind of some studies about that? Could there be some adverse impact on the flora and fauna from this abundance of the electromagnetic fields around us?
Okay, I have no clue. But if you ask about fauna and flora and fauna, then I guess the climate change is a much bigger impact. So I'm not sure about RF impact on plants. I have no idea about.
Okay. And one funny but important question, nevertheless, I would like to ask: if you could swap lives with any fictional character for a day, who would it be, and what would you do in their shoes?
Okay, swapping shoes with a fictional character.
Yeah. So you become that character for a day. You are not Andris anymore. You're someone else.
So one book that has inspired, or there's a like a, and it's not just the book. So the book was recommended by Professor Martin Taimer from TU Dresden, and it's a book by some not well-known German sci-fi writer, but he has very good space background. Maybe has worked in space as well, and it's called Paradox, I think. Yeah. So basically, they are traveling to the edge of the solar system, and then it goes on afterwards as well. But basically, that book describes how universe-wide travel would look, when you approach the speed of light and things like that. So how your environment changes when you're sitting in the spacecraft. So different view than we think that we're sitting here on the Earth and the time delusion happens, or how was it called? But they're like how your physics change when you're on the spacecraft. I guess that has the recent years inspired me kind of in like thinking that how beyond solar system travel could look like, although still just an imagination in terms of technology for now.
So your kind of desire to feel, to be in this kind of shoes of the person who is traveling in deep space.
Yeah. It's because you formulate that question that way, and that story has inspired me both from writing point of view,
right,
and from science point of view. But in general, I'm not that guy who is saying that, I would like to go to Mars.
right.
But if in my life, and because Mars is far and will be difficult in one way or another, but going to low Earth orbit, going to the moon, yeah, amazing. I think so. I like traveling. I've been to a lot of national parks in the US and trying to see as much as possible in Europe now. And whenever you enter a new ecosystem or environment, it has a different feel about it. And so desert has one, Grand Canyon has one, seaside, swamps, and then low Earth orbit probably has different feel than the moon. And I would love to experience that without losing several years of my life.
Great. So we are done with this job interview. And now I would like to ask you, how did you feel it's going? Was it similar to your previous experience?
Yeah, okay. It didn't feel like a job interview, but it was very exciting discussion, I would say.
You usually wouldn't sit with the person who is hiring on the software.
Yeah, but I'll be frank, I haven't had proper job interview in my life. As I said, things happen through personal connections. You write a proposal and then you either get funding or you don't.
Which were maybe kind of job interviews.
Yeah, true.
But in an informal setup.
Yeah, in written form, I guess. Yeah, science happens in written form. You're evaluated in written form. Although with big fundings, they organize interviews on, I guess, a bit different level than job interview. Well, you certainly surprised me with some of the questions, and I had to come up with some strange answers on the go. And I guess that is very good for a leadership interview, because the leader is the first person who deals with uncertainty. And I guess leader somehow works as a buffer between the rest of the team. I often think that when should people find out about something new, an update, or when they are capable to take up new information. And if I make mistakes, then I can hear feedback from them, especially from students who are very open to share their thoughts and ideas.
Mm-hmm. And people who are watching, listening us, they in Latvia and Estonia, other countries around the globe, different kinds of people. Some experienced, some are less. But let's say the person who is watching, who is just graduated or in the beginning, aspiring engineer, scientist, what advice would you give to that person?
Oh, that's very simple. Get hands-on experience as soon as possible. High school, I'm working with high schoolers. You can reach out to me if you like 3D CubeSat simulations, communication simulations as well. So that is, I think everyone in AsteCube and in Aalto and any other CubeSat project will agree on this, that as soon as you start to build things for real and you start to think that how it would work in real life, be it a formula, a phone or chat client or a satellite, doesn't matter, then it constrains you heavily. And if you do it as a student, low budget and low other resources, even low understanding of it, you have to be creative. And this creativity is not something a teacher can design for you. I guess as a teacher, as I said before, the best I can do is to give exciting problems, but then creativity happens here individually. And we all need to have our own aha moments when you're like, oh my God, I understand this. And that's true education. It doesn't come from the teacher.
Thank you. That was Professor Andris Slavinskis in the episode of Leaders and Engineers. Thank you for watching and listening us.
Thanks. Subscribe.